So, welcome students. This is another video regarding batch normalization in Unit 1. So, batch normalization, actually in this video we are going to see about first we are going to see what is normalization, then what is the effect of normalization in the feature set of the data set, and why we are going to see also that why the neural network or the CNN architectures rely on this batch normalization. That means what is the benefit of batch normalization in CNN and how it works. Okay, so basically batch normalization is nothing but it is an another layer of neural network which will be there commonly in most of the architectures like BGG, AlexNet, LayNet, etc. And this will be added in a convolutional block. Okay, there will be already in the last class I have shown you. For an example, I have shown you BGG net architecture and AlexNet architecture, right? In that, if you remember, you have noticed that there are many convolutional layers are there, then which is followed by max pooling layer, then again another set of convolutional layers, and all these things contain some of strides, filters, etc. Okay, so this batch normalization layer will be a part of your convolutional block. And what is the benefit of this batch normalization? It helps to stabilize the network during training. Stabilization means it will not oscillate, or what is the ultimate motto of an CNN model or an architecture or any model? It has to converge, right? We have to find out the error, and that error should be minimum. Then our model is trained very well. Then we are going for testing. So all these processes are same. So this batch normalization is a technique which helps the training to stabilize, that is the training to be properly going without oscillating or without diverging. Okay, then why we require normalization? What is the need of normalization? See, uh, for example, in data science, you all have gone through the data science, right? In the previous semester skill lab in data science, in that data science you have seen many data sets, right? In that data set, see, for example I am taking a data set. In my data set, some students names will be there, their age will be there, their marks will be there. Okay, so their names will be categorical value because they are in the names, right? They are in the categorical value, it will not be numerical value. But the age and the numbers, marks, which are in the numerical values, and the age will be only, it will be in between 17 to 21, or maybe 17 to 22. I can say that in between 20 to 21 or in between 20 to 25. Okay, I am taking that bracket of 20 to 25 is my age group. In that data set, marks ka data set will be out of 100. If suppose my marks is out of 100 and maximum marks are in the range of 80 to 100 or maybe 70 to 100. I have taken a small example, and in that this much variation is not there, but still you can see my inputs are, my age group is between 20 to 25 and the marks is between 80 to 100. There is a variation between 20 to 25 and 80 to 100, right? In the same way, if I am taking a bank data set or an insurance data set or a medical data set, in that data set, amount, how much amount he has deposited, maybe it is in lakhs. What is the last drawn? There will be many columns, right? If I'm taking a bank data set, there will be many rows, there will be many columns. So in those who have remember in the data science, okay, we are in a data set, which are the rows are called the instances or the person's name. If I'm again coming back to the insurance data, okay, then the rows are will be the person's name, Ashwati, then Suyash, then Pragati, then some names will be there. Then rows will be the features. Rows will be how much amount will be there in the bank account, then how much he deposited in the last month, how much he withdrawn in the last month, how much after taking that account, how much he withdrawn from the first to the last, then uska age hoga, then uska salary hoga. I mean, many things will be there in that. Okay, so in that case, the feature numbers or the features are ranging from a different values. Something will be in lakhs, something will be in numbers like in less than 50 numbers ages, and iska salary maybe again lakhs, then the deposit may be again some other, maybe it can be crores, right? So it can vary from different. So in that case, what is the normalization required? We need to normalize all those features. Otherwise, what will happen? I will show you. So why we need it? When inputting the data to a deep learning, I'm reading the first point. So it is standard to normalize the data. Why we need normalization? Right now I said, right here, if suppose I am having x1 to xn features are there, and x1 is ranges from 1 to 5, but x2 is ranges from 1000 to 10,000, there may be the difference. So what is will happen? So for each feature column separately, we need to normalize. How will we normalize? We take the values of all samples in the data set. Samples means instances, the rows wise or the name wise. Okay, that samples. So each values in the columns we will take for each samples. Then we will compute the mean and variance. Okay, so we are having for each feature vector, I am having a mean and I am having a standard deviation. Then I am going to normalize by using the formula xi equal to, xi means the current vector, xi minus mean I by standard deviation I. That means we will get zero mean unit variance. Okay, this equations gives us zero mean unit variance normalization to all the features. So what will happen? We have, see, what is this figure shows the blue dots were the previous features, and after normalization all the features are centered means they are all more or less similar values they came. So what is the benefit of coming to normalization? Here comes again, we are going back to the gradient descent. What will happen in the first one? In the first one we can see a high ravine. Ravine means nothing, that space, it's having a high space, right? So in that space, what is happening? Features are on different scales. So what will happen? The gradient descent take longer to reach the minimum. See, from here we can see some positions it is taking steep increase, then some where it is taking the gradual steps. Okay, so it will take much time to reach the minimum. But in the second figure, what happens? It is the normalized data. That is, it is more or less looks like a bowl. It is more or less looks like a bowl like this. So it is easy to travel to the minimum for the gradient descent. Then again, what is the relation between gradient descent and the training? The training becomes faster. The training will give us the minimum. I mean, it will guarantee that our training model reaches the global minimum. Okay, so what is batch normalization in CNN? See, in a CNN layer, what is there? We are having input layers, then we are giving that inputs to a another layer of convolutional networks, then we are having an activation, then we are giving to another network layer, that will be mostly hidden layers, right? Layer 2 to layer 2, layer 3, etc. will be hidden layers, and layer n is the output layer. Okay, so what will happen if I am blacking out this input x and layer 1? Then directly the activation functions is going to layer 2, that is hidden layer, that is directly the input is giving to the layer 2. We can say that by, so what will happen? By normalizing the activations from each layer, each prior layer, that is the layer next to before the hidden layer, the gradient descent will converge more effectively during training. I mean, it's not clear. I will correct that. See here, if we are adding a batch normalization in each layer before going into the next layer, what will happen? The activation functions, the networks or the values after activation functions are going to normalize, and that normalized values are getting passed on. So nowhere it happens that without normalization, no values will be passing to the next. So it will be easy for gradient descent to converge. Okay, the same thing has written below. Batch normalization is another network layer that gets inserted between a hidden layer and the next hidden layer. So in between linear 1, linear 2 is the layers. In between linear 1 and linear 2, the batch layers have inserted inside that, right? And its job मतलब batch normalization layer का job क्या है? To take the outputs from the first hidden layer, normalize them before passing them to the next hidden layer. Okay, so this batch normalization figures are important. This is the without batch normalization and this is the with batch normalization figure. Okay, thank you. We will see in the next class.